Okay, question 9 part B, writing out the truth table. So a couple of approaches to this. One of the probably the easiest approaches is if you're confident in drawing out your logic circuit and you think that's pretty accurate, use that to help you draw the truth table or write out the truth table. And the thing that I suggest doing is labeling the output of each gate. So we've already used A, B and C, so we're going to go ahead and start labeling our gates. So we've got D. I'm working from left to right and make sure each and every single gate has a label. F for the NOT gate. Now technically the OR gate here does have a label that's Z, but if you're just comfortable just using this as a method and you want to give it a label, let's go ahead and give it a label here, G. Next thing we do is we're going to pop those labels in our working space, D, E, F and G. Now before we go ahead and start figuring out the answer, one thing I recommend doing, just a tip for this, is write down the truth tables for each gate. That way you don't have to try and work them out in your head when you're in an exam situation. So the first gate we got is the NAND gate. Now if you can't remember the NAND gate, I bet you remember the AND gate. So the AND gate, we only get a 1 out when there's a 1 on A and B. Now the NAND gate is simply the inverse or the NOT of that. So we can just flip each one of those round. So we've got our NAND gate. The exclusive OR gate or XOR gate is simply a gate where we only get a 1 out when the inputs are exclusive or when the inputs are different. So in this case we're going to get a 1 here and a 1 here, and where they're the same we're going to get a 0. And then I'm not going to worry about the NOT gate, because the NOT gate we're just going to make whatever it is opposite. The last one we've got is the OR gate. Oops, 0, 1, 1, 0, 1, 1. And for the OR gate, we know that we get a 1 out when there's a 1 on any of the inputs. So that's a nice easy one. So now we've done those, we can go ahead and tackle the question. So D is A NAND B. So there's A and B. We could look at each one, and so the first one is A and B 0, 0, so that's going to give us a 1. Or what I like to do, and it doesn't matter which way you do it, I know that with the NAND gate we only get a 0 when they're both 1. So if I look down here at A and B and look for when they're both 1, and then I know that's going to be a 0, so that they're both 1 here and they're both 1 here, I know the rest are going to be 1. E is the exclusive OR gate, and for this time we know that for the exclusive OR gate we get a 0 when they're both the same. So I'm going to do the same thing again, but this time be careful that you don't start looking at A and B, because remember the exclusive OR gate is connected to B and C. So we're looking at B and C this time. So where B and C are the same, we're going to get a 0. So they're the same there, they're the same there, they're the same there, and they're the same there. The rest of the time they're 1. F is the NOT of E, so we just worked out E, so we're just going to make that opposite. And then finally G is D or F. So again, be careful because D is there and F is there, so always just be careful, make sure you're looking at the right columns. So for this time we know for the OR gate we're only going to get a 0 out when they're both 0. So again, you can look at each one, or I'm just going to go ahead and look down for a 0 and see if the other side is it. So we've got 2 zeros here, so that's going to be a 0. The rest of the time we have a 1, so the rest of them are all going to be 1s. And actually G, there's nothing from G to Z, so that is our answer. So let's go ahead and fill in our answer column. It does not matter what's in here, because the examiner is just going to look at what's in the Z column. So that's our answer. if you just have the logic expression, you can use the same technique, but what you would probably do is you would just come up here and you would label, so that would be D, because if we do the brackets first, that would be E, that would be F, and then finally that would be G. And instead of writing, well, you could write the letters in, or you could actually write, so instead of D you could write A and B, but it doesn't matter. I would suggest if you have the logic circuit, do what we've done on here. So looking at the mark scheme, it's a nice and easy one to mark this. They can just look for a 0 there. If they see a 0 there and the 0 there and the rest are ones, then it's 4 marks. If you completely don't have a clue and your mind goes blank on this one, then if you're going to guess, you're probably better off guessing either all ones or all zeros, and you're likely to get 1 or 2 marks. But obviously you're much better off learning the truth tables and the gates. These are nice straightforward questions to pick up loads of marks. Try and practice as many as you can as well, because you know this is coming. Right, let's stop this one and move on to the last question.